Okay, we are learning a new function today. Actually, you've been introduced to this function called the cubic function, but today we're going to explore it a little bit more in depth. And I want you to start by graphing this on your graphing calculator. Y is equal to x cubed, and you just are going to enter x. Use your little caret top symbol there and raise it to the third power. My window is negative 10, 10 with my scale 1 for both my x and y. Go ahead and hit graph. And then I want to look at what we have here. So it crosses once at 0, 0, and it has a point of inflection there. We talked about this sort of as a twist, meaning that the factor there repeats 3 times, and it's called a triple root there. So the data table that I want to look at is do second table. And the main thing I want you to focus on are if you had input a negative 2, a negative 1, 0, 1, and 2. So think of that as your data table that you used to do way back in Algebra 1. And you'll see if I input a negative 2, I go down by 8. A negative 1, I go down 1. 0, I don't move at all. And then 1 cubed is 1, 2 cubed is 8. So that's kind of what we're looking at here. And it is the cube function, so all we're doing is taking the value, for example, negative 2 times negative 2 is a positive 4, and then again times negative 2 is a negative 8. So that's where we're getting the negative 8 from right there. Okay, so let's sketch this. And this is really important that you do this pretty precisely. For these at least. You can see these on the graph. And then, so 8 would be right here. Okay, so we're going to sketch that in place. And this is our new function. And with everything, it can be moved around, translated. For example, it can be stretched, compressed, it can be reflected. There is symmetry here. It's rotational, 180 degrees about the origin, meaning that this parent function of the cubic is an odd function. Okay. Now, what if we change the equation to plus 2? And I'm going to kind of go through this pretty quickly. It's going to shift up by 2. I'll show you real quickly on the graphing calculator. When I do plus 2 and graph it, it has shifted up by 2. It's supposed to shift up by 2. See what I did? I made a mistake there. Make sure you do the plus 2, not as part of the exponent. So shifts up by 2, but it's the exact same shape. So it's just a rigid transformation up 2. So up 2, and that would be a vertical shift up by 2. And this is going to, if you subtracted 3, it would be shift down 3. Okay, so we're going to start to talk about something today called a translation point. And it's basically where is your starting point or your origin being moved to. So this is going to move up by 2, so it's going to be 0, 2 instead of 0, 0. This will be 0, negative 3. Okay, complete this sentence. The translation point on the graph of x cubed plus k is going to be at 0k. This is just a general way of thinking about it. And then what could you change to make the equations in the graph flip upside down? Well, that's when you put a negative a out front. It's really just a negative out front. Okay, and on that note, something I did in class, I had everyone write down y is equal to a x minus h cubed plus k. And then you know the translation point is always going to be h comma k. And A is going to tell you if you have a stretch or a compression or a reflection. I'm going to do some examples of that in just a minute. So A is going to be reflected or imply that you reflect if negative. An A value larger than 1, and I'm just going to say an absolute value of A. So if it's a negative 2, for example, it's reflected and it's stretched. So absolute value of A greater than 1 means it's stretched. And then an absolute value of A less than 1 basically means it's going to be between 0 and 1 is going to be a compression. And like I said, we're going to do some of that. Okay, so I'm not going to finish all the notes on here. That's the gist of it, so I'd rather get to some of the examples. So this was classwork, and I checked it by the end of class because there's also a homework assignment as well. So let's just do a couple of these. So this is going to shift down by 3. So my translation point is 0, -3. So just go down by 3. And remember, you're going to apply what are called moves to this. And this is not actually a data table. This is more what we call your moves. So when you go 2 to the left, you're going to go down 8. 1 to the left, down 1. 0, of course, is 0. 1 to the right, you go up 1. 2 to the right, you go up by 8. So I'm going to apply these moves to my graph. So 1 to the right, 1 up. 2 to the right, I'm going to go up. I need to go up to 5. I think that's right there. So 2 to the right, I would go up 1, 2, 3, 4, 5, 6, 7, 8. Very good. 1 to the left, 1 down. 2 to the left, I'm going to go down by 8. I'm just going to kind of make it look symmetrical and then sketch it in place. So you don't actually have to do a data table once you know these moves a little bit better. Okay, let's do number 2 together. It has been translated to 0, 3. But then I also see this -2, which is going to reflect it because of the negative and stretch it because of the 2. So I'm going to first start by moving up to 0, 3, translate up. Now, normally when I go 1 to the right, I go up 1. Now I'm going to essentially multiply that by the -2. So 1 to the right, I'm going to go down, but I'm also going to stretch it by a factor of 2. 2 to the right, I'd normally go up by 8, but instead I'm going to go down by 16. So I'm way down here, just put a little point, kind of approximating that. 1 to the left would normally be down 1. And then instead of going up 1, instead of going to the left and going down 1, I'm going to go up by 2. I'm doubling that movement. And then if I go 2 to the left, I'd normally go down by 8. But instead, I'm going to go up by 16. It's way off my graph, so I'm just putting a little point up there. So really on this graph, these points way up high and way down low are just kind of giving me the overall shape. It's these in the middle, these 3, that are helping me out with that, with the actual graph. Okay, and it's just because we're off the graph there and there. All right, so that's how you do those. Let's do another one where you are going to compress, which would be number 4. So this is going to shift 4 to the left. And then if you want to think of it like a +0 there, it's going to actually shift 5 to the left, sorry. So -5, 0 is where my translation point is. So I'm going to go 5 to the left and put my translated origin right there. Normally I would go 1 to the right and 1 up. I'm going to go 1 to the right and only 1/3 of the normal movement. Normally I go 2 to the right and 8 up, but instead I'm going to go 1/3 of that 8, which is a little bit less than 3. So I'm just going to put a little point right there. 1 to the left, 1 down typically, but I'm going to go 1 to the left, 1/3 down. 2 to the left, and I go down almost 3. So this is the general shape. It's compressed. It's a little bit less stretched. It's compressed, so it's going to be a little bit more squatty. It's hard to describe that. But that's how you're going to do those. Okay, let's do another one. And let's do number 7. I think I did that one in class with everybody. So 0.25x cubed is really just 1/4. So just think of this as f of x is 1/4 of x cubed. So this is not translated at all. It starts at 0, 0. And when I go 1 to the right, I normally go up 1. I'm going up 1/4 of that. When I go 2 to the right, I normally go up by 8. But I'm going to say 8 times 1/4, which is 2. So I'm now only going to go up by 2. So 1 to the left, down 1/4, 2 to the left, down 2. And I'm just using symmetry for that. And this has been compressed by a factor of 1/4. Okay, let me do one more on the front. Let's do number 6. My translation point is 1 to the left, 2 down, so it'll be a -1, -2. So here I am, and it's reflected because of the negative, and it's compressed. So I'm going to move 1/2 my normal movement. So 1 to the right would normally go up 1, but instead I go down 1/2. 2 to the right would normally go up by 8, but instead I go down half of that, which is down by 4. So I'd be down here. 1 to the left, I normally go down by 1, but I go opposite. I go up by 1/2. And then 2 to the left, I'm going to go up by 4. So it'll be up here. And it's been reflected. And then plot all your points there. Okay, one thing I pointed out in class is that once we start talking about the other characteristics, such as increasing and decreasing, these are a little bit easier because these either increase or decrease over the entire interval of x's. So for number 6, for example, because it was reflected, it is decreasing over all of my x's. So I would say my intervals of decrease are negative infinity to infinity. I would have no intervals of increase. So that's actually a lesson for another day, but I just kind of wanted to touch base on that. Now, on the back, these are some that we did as notes as well. The graph of f of x is equal to x cubed has been transformed so that the translation point is 4, -1. So it's almost like I'm working backwards on this one. So I know if it's a positive 4, it must have been x minus 4 inside the parentheses, and then -1. So remember, you always change whatever the sign is in here. It's because of the equation. You're not actually changing the sign. It's the fact that here, if it's, for example, if it's x minus 4, h is a 4, and that's where this h is coming from. And then plus k just means always use the sign here, always change the sign there. Now, number 11, the translation, or f of x has been transformed, so the translation point is still 0, 0, but it now goes through the point 1, 5. So a quick little sketch of this is helpful. So normally I would be right there, but instead I'm way up here at 1, 5. That means when I went 1 to the right, I went 5 up. So it's stretched by a factor of 5. So this is just going to be f of x is equal to 5x cubed, just like that. Okay, so I'm going to let you finish the rest of this on your own, just like we did in class, except for down here, generalizing the rules. Anytime you have a function, even if it's one that's not an actual function that we have an equation that we're learning, it's just a sketch, and you did this back in 9th grade. V of x is shifted down by 4, you would just say v of x minus 4. If it's flipped upside down or reflected, it would just be a negative v of x, just like that. And if you want to shift it 5 units to the right, you're going to say v, and it's going to be x minus 5. That will shift it 5 to the right, no matter what the parent function actually is. So this is going to be useful for every function that we learn this unit. Okay, so let me show you how to do this next one. This is going to translate 2 to the left and 4 down. So 2 to the left and 4 down. So I'm going to essentially start by translating, and I'm going to move 2 to the left and 4 down. So my translation point is -2, -4. Then what I'm going to do, because there is no stretching, I'm going to go up here and I'm going to apply the moves that I see here. So from the origin, 1 to the right would be 2 up. So 1 to the right is 2 up. 2 to the right is 3 up, so I have another point there. 2 to the right is 3 up. And then when I go 4 to the right, I go 4 up. So 4 to the right, 4 up puts me right there. And I'm ready to put that half of it in place. And it's just an approximation, so that's what that would look like roughly. So all that's really happening is that it is a rigid transformation from the origin 2 to the left and 4 down. So now I'm going to do the same thing on the other side. When I go 1 to the right, 1 to the left, I go 2 up. When I go 2 to the left, I go 3 up. So it should be pretty symmetrical anyway. And then 4 to the left is 1, 2, 3, 4 up, just like last time on the right side. And it puts me right back there on the x-axis. So it's symmetrical, fairly symmetrical, Yeah, I think it's pretty much symmetrical. And I did the same thing down here. So there's